Hello friends, welcome to lecture number 16 of complex analysis, and today we are going to solve exercise problems of mathematical physics books by H.K. Das, and the topic based on the questions will be based on Cauchy's integral formula, and we have already discussed about Cauchy's integral formula, Cauchy's integral formula for derivative in lecture number 14 and 15. Okay, so first what's these two videos. Okay, so links are given in the description box, so you may go through. And before we start, please subscribe the channel, hit the bell icon so that you get notified when new video will be uploaded, and also share with your friends and help me to grow my channel, inspire me to create new contents for you. Okay, and hit the thumbs up button as well. So now let's start. Before we solve problem, first let me remind you the Cauchy's integral formula. Cauchy's integral formula. And that was f of a 1 by 2 pi I integration along c f of z, which is a function of complex variable z, over z minus a dz. Okay, and from here you can evaluate integrals. F of z by z minus a dz, that's going to be equal to 2 pi I into f of a, right, at a point z is equal to a, right? So this is very important, so we're going to use this, right? And also we need the Cauchy's integral formula for derivative. So that was, let me write here, and the Cauchy's integral formula for derivative, that was f dash at a 1 by 2 pi I integration along c f of z by z minus a dz, here whole square, right? This was the formula. And for nth order derivative, for nth order derivative, so what was the formula? F nth order derivative of f at the point a, that is factorial n divided by 2 pi I integration along c f of z by z minus a whole to the power n plus 1 dz. Okay, so this can imply that integration of f of z by z minus a whole to the power n plus 1 dz, that's going to be equal to 2 pi I by factorial n nth order derivative of f at the point a, right, at the point a, right? So using this we're gonna evaluate this kind of integration. Okay, so hope you have understood this. Now let's move on to the exercise. So this is the first question we're gonna evaluate, right? I have not mentioned the exercise number here because in different editions of the same book the exercise number may be different. Okay, but when you're gonna check the exercise that based on this Cauchy's integral formula, then you're gonna get the same kind of problems. Okay, I have not mentioned the exercise number. Okay, so now you see, first let me solve this one first. So here the given function is this. So first let me write this one, integral is this one, right? So here c is a simple closed curve, right? C is a simple closed curve. Let me copy this one here, just do it. Yes, C is a simple closed curve. Okay. So here we're going to apply the Cauchy's integral formula, right? So here you see what was the Cauchy's integral formula. So Cauchy's integral formula was f of a, that is 1 by 2 pi I integration along c f of z by z minus a dz, that is that, right? Now we're going to compare this one with this part, right? So that's why let me simplify this one as we're gonna simplify this as integration of f of z over z minus a dz. That's gonna be equal to 2 pi I f of a. Right, now here you see, so we're gonna use this form of the formula, Cauchy's integral formula. This is the form, right, by Cauchy's integral formula. Right, so here you see, if you compare these two, this one and this one, so you're gonna get here f of z is nothing but here 1 in this case, and here z minus a is here z minus a, these two are same. Okay, that's no problem here. And here you see, if z is equal to a outside C, then integration along C f of z by z minus a dz, that's gonna be 0. That's gonna be obviously gonna be 0. Here f of z is nothing but 1, so this is gonna be 0. So now if it is inside C, if z is equal to a inside C, then what are we gonna get? Okay, now you see, let me copy these things and let me go to the next slide. Okay, now let me go to the next slide. Here you see, so now here you see we have got f of z is equal to 1, so it is a constant. F of z is equal to constant, then obviously f of a, that's going to be also 1, right? So f of a gonna be also 1, because here you see this is constant, this is 1, there is no variable, so that's why f of a gonna be also 1. So now you see, as we know that integration of f of z by z minus a dz is equal to 2 pi I into f of a. So here integration along C, f of z we have considered, we have got here 1. This f of z is 1, so that's why you're going to put here 1 by z minus a dz. That's going to be equal to 2 pi I into 1. So that's going to be 2 pi I. This is our answer. Okay, so hope you have understood. So now let me take another question. So now we're going to solve this. So here you see the given function is the given integral is this one, right? So here the C is a circle, the mod of z is equal to 2 means radius is 2. So here we can say this is suppose y-axis, this is x-axis, and let me write it properly. Okay, this is x-axis, x, this is y, right? And this is a circle. Let me, so here mod of z is equal to 2 means it is 0, that's this point gonna be 2, so here it is 1, right? So now you see, let's find pole of integrand. How to find a pole? Just equate the denominator, to find pole. Here let me write here, just wait. What are you going to write? To find pole, z minus a equal to 0, so z going to be equal to 1. So this is pole. So what is pole? We have already discussed earlier. So what's all the previous lectures, then you're going to know what is pole, right? So now you see, now let me tell you one thing. Suppose this circle is given this way, z minus 1 is equal to 2, then your center gonna be at 1. Okay, remember that. So now we have mod of z is equal to 2. Here center is gonna be at origin O, and radius is 2 here. Okay, So now you see, so this pole must be lying inside the circle. Okay, remember that thing. This pole must be lying inside the circle. Okay, then we can apply Cauchy's integral formula to evaluate this. Okay, now again by Cauchy's integral formula, we can write integration along C f of z by z minus a dz is equal to 2 pi I f of a, right? We can write that one. So here you see, here we can compare f of z minus a with z minus 1, right? So here we can say that z minus 1 is equal to z minus a, or you can say z minus a equal to z minus 1. In that case, a gonna be equal to 1 here, and f of z, here f of z is nothing but e to the power z, right? F of z is e to the power z. Okay, f of z is e to the power z. Then what gonna be f of a? Then f of a, if you put f of a, then this z should be replaced by a. Then we're gonna have e to the power a, and e to the power a, and value of a is 1 here. Since the value of a is 1, so a gonna be replaced by 1. So here we're gonna get f of 1 is equal to e to the power 1, that means e, right? So here you see, now f of z will be replaced by e to the power z, z minus a is replaced by z minus 1 dz 2 pi I f of a, means here we're gonna have e to the power a, and value of a is 1, because here function of here you see, because as you see, as I have already told you, here f of z is e to the power z, e to the power z. So f of a must be equal to e to the power a, and value of a is equal to 1. So e to the power a means e to the power 1, that is e, right? So hope you have understood this. So now let me clean this. So here what we're gonna have, e to the power 1, that is equal to 2 pi I e. So this is our answer, right? So hope you have understood this. So here is the next question. So let me write the solution here. So this is we need to evaluate. Okay, and the circle C is mod of z is equal to 3 here. Okay, so let's make the circle. So this is x and y axis, suppose this is x, this is y axis, and here is the circle, right? This is the circle, and here you can see this radius is 3, so this is 1, 2, and this must be 3, right? This is 3. So again we're gonna find the pole of integrand. To find the pole, we're gonna equate the denominator with equal to 0. So that's gonna be z is equal to here 1. So this is the pole of integrand. Right, this is the pole of integrand here, and this is within the circle, right? This is within the circle. So here you can see that again the Cauchy's integral formula. What we can write here, integration along C f of z by z minus a dz is equal to 2 pi I f of a, right? We used to get this, right? F of a, right? Now let's compare this one with f of z, right? And denominator with the denominator, and so on. Then what we're gonna have comparing these two? So we're gonna get f of z is equal to cos pi z, right? Cos pi z, and z minus 1, here it is z minus a gonna be equal to z minus 1, z minus a going to be equal to z minus 1. That means a is equal to 1 here, right? A is equal to 1. So now let's find f of a. Okay, so here f of z is equal to cos pi z, so f of a, that's going to be equal to cos pi, z means here a is going to be a, and a is 1, so f of 1 is cos pi, right? Here it is cos pi. So what is the value of cos pi? That is minus. So what we can write, integration just wait, let me copy these things and let me go to the next slide. Okay, just let me go to the new slide. So here these are the things that we have got. So now therefore integration cos pi z by z minus 1 dz, that just replace the f of z by this and z minus a by z minus 1, right? And here f of a will be replaced by f of 1, right? That's going to be 2 pi I f of 1, and f of 1 is nothing but 2 pi I f of 1. We have got here minus 1, so this is minus 1, so therefore its answer is minus 2 pi I. So this is our answer, right? So hope you have understood this. So here is the next question. You can solve this. So let's solve this one. So what is the integrand here? You know, c cos of pi z square divided by z minus 1 into z minus 2 dz. So where the circle c is z is equal to 3, right? So again let's make the circle. So here again this is origin O, 1, 2, and this is 3, right? So now let's find the poles. To find the poles, so here we're gonna get two poles, z minus 1 into z minus 2, and if you solve this, z minus 1 equal to 0 and z minus 2, that's going to be also equal to 0, either this one 0 or this one 0, right? So from here we're going to get z is equal to 1, and here we're going to get z is equal to 2. Therefore poles of integrand are, so what are the poles? Z is equal to 1, 2, and these belongs to the, these are enclosed by the circle, okay, are in the circle. That mention this thing also, in the circle, see, mention that one also. So now you see, again we're going to apply the Cauchy's integral formula, f of z by z minus a dz, and equal to 2 pi I f of a. That's what we're going to do, right? So but here you see, in the denominator you cannot compare with this, right? Because there are two factors, okay? So what we're going to do here, first we're going to evaluate this around a circle including one that encloses 1. This is suppose C1, and the circle encloses 2. This is suppose C2. So let me draw it clearly. Let me draw it more clearly. Just wait. This is the y and this is x. So this is the circle. Let me make it bigger. This is the circle, okay? This is 0, 1, this is 2, and this is 3. This is 3. This is 2. So here you see, so we're going to integrate it along this circle C1, which encloses 1, and C2, which encloses 2, right? including these two poles. So when we're gonna integrate it along C1, right, then what we're gonna do, so we're gonna write this as this one C1, or you can do one more thing, just wait, okay, cos 2 pi z square. So first, in order to integrate along C1 which encloses 1, just keep this factor as a denominator, and let me write z minus 2 here. Okay, so hope you have understood this. So just to do one thing, let me take a new slide. Okay, let me copy these things. So here you see, or you can write this way, integration along C cos pi z square by z minus 1 into z minus 2 dz. It can be written this way, integration along C1 cos pi z square. C1 encloses this circle. C1 encloses the pole 1, that's why here we're gonna keep the denominator z minus 1 here, and this one should be written below this. Just wait, we're gonna write the z minus 2 here, okay, dz. Then again we're gonna integrate this along C2 as well, then cos pi z square by z minus 1 now divided by z minus 2. So as we are integrating this along C2 includes the circle C2 encloses the point 2, this one, right? So hope you have understood this. And for this first case, this one gonna be the f of z, and this one gonna be f of not f of a, this is gonna be z minus a, right? So for this case, just wait, for this first one, so now just do one thing, let me clean all these things, or let me copy this and let me go to the new step, new slide. Let me take a new slide. Here you see, this is the thing that we are gonna deal with. So here you see, for this case, for the first case along C1, in order to integrate along C1, f of z, that's gonna be cos pi z square by 2z minus 2, and so f of a, that's gonna be equal to cos pi a square divided by z minus 2, and here z minus a is nothing but z minus 1, and here this should be actually a minus 2, right? Because now instead of z we are putting a, this z should be replaced by a, right? So hope you have understood this. Now this a gonna be equal to 1. So if a is equal to 1, put here 1, then what are we gonna have? F of 1, that's gonna be cos pi 1 square by a minus 2, and that's gonna be equal to f of 1, that's gonna be equal to minus cos pi, and minus cos pi is again, just wait, let me write these things here. Cos pi itself minus 1, again that's going to be 1, right? So that's why if you apply this here in this first case, then you should get 2 pi I f of 1 here. You see, in this case f of 1 is nothing but cos pi 1 square by z minus, instead of z we're going to write here 1 minus 2, right? So hope you have understood this. So we are putting this, okay? So then, okay, now let me delete these things. Just wait. Now what if we integrate along C2? Along C2. So here, this is the f of z. F of z is here cos pi z square by z minus 1. So f of a gonna be equal to cos pi a square by a minus 1, right? So f of 1, so here not f of 1. Now here you see this z minus 2 is the z minus a, so that's why a gonna be equal to 2, right? So we're gonna put f of here 2. We're gonna take f of 2, that is cos pi 2 square by 2 minus 1. So here what we're gonna get, 2 pi I f of 2, right? And what is f of 2 here? F of 2 is nothing but cos pi 2 square by 2 minus 1. That's what we're gonna get, right? So here you see, just let me cut this. So 2 pi I, so this cos pi is minus 1 and 1 minus 2 is also minus 1. So here you see this is gonna be cos 4 pi, right? Cos 4 pi, and cos 4 pi, we know that cos n pi is minus 1 to the power n. So here it's gonna be minus 1 to the power 4, and that's gonna be plus 1, right? So here what we're gonna get, 2 pi I minus 1 to the power 4 divided by 1, right? And this is 2 pi I minus 1, that's going to be plus 1, right? Then here 2 pi even power of minus 1, that's going to be again plus 1. So here we're going to get 4 pi I. So this is our answer, right? So hope you have understood. This is the next question. Let's solve this one. Okay, here is the given integrand e to the power 2z, and along C here z plus 1 whole to the power 4. That's what we have, dz. Okay, and the given circle is mod of z minus 1 is equal to 2. So let me draw the circle here. Here this is the x-axis, this is the y-axis, and the circle should be, you know, the center should be at 1, okay, not at the origin. Okay, this is minus 1, because radius is 2, so this is 2 and this is 3. So since the center is 1, so the radius is 2, that here that this circle must cut x at x is equal to 3, right? X is equal to 3, because you know, for 2 units from, you know, x is equal to 1, so it must cut the x-axis at 3, because the center is at 1 now, not at 0, right? So this is 2 units, right? So hope you have understood this. So what gonna be the pole? To find pole, so let us take z plus 1 whole to the power 4 is equal to 0. So that's going to imply z plus 1 is equal to 0 and z is equal to minus 1. This is the pole of the integral, right? So here you see this is on the circle, this is on the circle, so this is not outside the circle, so this is on the circle because radius is 2, right? So from 1 to minus 1 the distance is 2 units, so this is on the circle, so this is on C, right? So hope you have understood this. So now you see we have got the Cauchy integral. So as we have power 4 here, right? So we can compare with the Cauchy integral formula for derivative. Cauchy integral formula for derivative for nth order derivative. That is nothing but, you know, integration along C f of z by z minus for nth order derivative. It should be z minus a whole to the power n plus 1 in case of nth order derivative, and z is equal to 2 by I. Here it should be factorial n, and f nth order derivative of f at a. That's what we have got, right? So here you see, in this case n plus 1 is nothing but 4, so that's why n gonna be equal to 4 minus 1, that's gonna be equal to 3. So now let us find third order derivative of f at a. So what gonna be the a here? So now let me write that one also. So here a is nothing but z minus a is equal to here z plus 1, that's why a gonna be equal to minus 1 if you simplify this. Then first you see, first let us find f n a. So here n is 3, so third order derivative at a is equal to, what is the a? That is minus 1, right? So how to find it? First let us find first order derivative. Let us find first f dash of z. Okay, so what is f dash of z here? Just let me write here. First let me find f dash of z. So as you can see, just wait, f of z is e to the power 2z, and that is why f dash of z first order derivative, or you can write here instead of f dash, if you can write f1 here, that's going to be equal to, if you differentiate this is going to be e to the power 2z, right? Again, if you differentiate it second order derivative, then you're going to find 4 e to the power 2z. Then if you differentiate it again third order derivative, if you find the third order derivative, then it's going to be equal to 8 e to the power 2z. That's what we're going to have. So what we have got here, we have got this, right? So now let's find fn, this one, fn a, that means n is here, in this case n is nothing but 3, right? So third order derivative, so that's why we have to stop here, right? A is nothing but 1 minus 1, sorry, minus 1. So in that case let's put here minus 1. So here here it is z, so if you put a, then it's gonna be a, right? Okay, if you put a, so then it's gonna be e to the power 2 to the power z, 2 to the e to the power 2a, and value of a is nothing but minus 1, right? That's what we have got. So hope you have understood this. If you here you can see, if you replace this by a, then it's gonna be a, right? It's gonna be a, so a is minus 1, right? So hope you have understood. Now let me copy these things. Let me copy all these things, and let me go to the next slide. Okay, just wait. Give me a second. Now here you see, let us apply this one. So f of z is nothing but e to the power 2z. Okay, let's put those here. Then what we're gonna get, e to the power 2z, and instead of z minus a we have z plus 1 whole to the power 4 instead of n plus 1, right? So that's why n plus 1 is equal to 4, and which gives n is equal to 3, right? So if n is equal to 3, then here this factorial n will be factorial 3, right? So that's what we're going to have, 2 pi I by factorial 3, then f of na. So here we're going to have f of 3 a, sorry, not f of n, nth order derivative of f at z is equal to a. So here third order derivative of f at z is equal to a, and here a is nothing but minus 1. This a is nothing but minus 1 here. This is the value of a, and this is third order derivative of f at a is equal to minus 1 is this, right? This is equal to, that's going to be equal to, and that's going to be equal to 8 e to the power minus 2, right? So let's put this value, then here you're gonna get this answer. Here you can see 2 pi I by factorial 3 into 8 into e to the power minus 2. Now let me copy the last step and let me go to the new slide. Okay, so here you see, so this is the last step that we have obtained. So integration along c e to the power 2z z plus 1 whole to the power 4 dz, that's going to be equal to, here you see, 2 pi I factorial 3 means 3 into 2 into 1, 8 e to the power minus 2. Here 2 going to be cancelled, right? This 2 cancels, so that's why the answer is 8 pi I e to the power minus 2 by 3. So this is the answer. So hope you have understood this. I hope that this video is helpful for you, and please stay connected, share with your friends. If you like my videos, hit the